Everyone, my name is Sitaf Qanat and this topic is about IP addressing. It's a very important information for computer networks, so let's start our slide. At first, we must to know that computer use other number system than we use. We use the decimal number system, but computer use binary number system. Why is it used them? It's because the binary number system simplifies the design of computers and related technologies. So we understand what is it used. It's binary number system. We understand why is it used them. This because of this. So let's to know what is this binary number system and what is the difference between decimal number system. The main difference is base number systems. In decimal, base is 10, in binary 2, in octal 4, 8, and so forth. This base defines the maximum number that possible in this number system. So let's see our txt file. So you can see here the range of all numbers, and you can see that binary use only 2 of them. Octal use only 8 of them. Decimal use all of them. Yes, you can see it. So let's continue. Okay, we know what is it, why is it, and where is it used. So how we can work with this, how we can convert it. It's questions because our numbers that we use in a decimal format, it's the same numbers that we use in a binary treatment. It's just a treatment from decimal to binary, and we must to convert our numbers to understand what it will be on a binary number system. So for understand this, to convert it, I'll show you as a txt file. So we have a table of numbers. These numbers is only for understanding logic. Why is these numbers stand here? And we have example of convert our numbers. So we have one decimal numbers and we must convert it to binary. We see this table and we start from first element and go to the next. It will be our algorithm. So we see our first element and we compare it with our number. Is it greater? Is this element greater than our number? No. So we take from our numbers number from this table, and the result right here, it will be 68. So we use this number in our operations, and here we put 1. So continue. We have this number 84, 64, 64, and we come to the next element in this table and compare it again. Is 64 greater than 68? No. So we put here 1 and take from our element in our table. Here it will be 4. So continue again. 4. And come to the next element. Here we put 1. Here we have 32. Is 32 greater than 4? Yes. It means that we put here 0 and don't use this in our operations. And come to the next element. Next element is also greater than 4, and we put here 0 again. 8 is also greater than 4, so we put here 0 and don't use 8 in our operations. Here we have 4 that not greater than 4 but equal. and we put here 1 and take from our 4 in this table. Result will be 0, and we come to the next element. Is 4 greater than 0? Yes, it's greater, so we put here 0 and come to the next element, last element in this table. We see that only 1 and 0 and compare it again. 1 is greater than 0, so we also not use 1. So we have these numbers, these ones and zeros, and put it here. 1 1 0 0 0 1 0 0. It's our numbers just in binary treatment. It's our number. So we understand how it's converted. So let's to the next slide. For our devices, it's like hosts, laptops, computers use this binary address to identify each other. One of these address is format is IPv4. IPv4 is a string from 32 numbers that contains only ones and zeros, and this string divided by 4 parts that calls octet. 1 octet, 2 octet, 3 and 4 octet. We have here. So continue. Our IP address is divided by 2 parts, a network portion and a host portion. First portion, that network, is identify a network, and the second portion, host. So here we see the page for this. We have IP address, it's divided by 2 parts, this for network, this for host. So continue. Host or some device should be assigned a strip address for configured. First IP address is IPv4 address. It's address of the host. It's IP address for laptop, PC, and so forth. We must have subnet mask. Second IP address for configured. This subnet mask is used to identify the network host portion of the IPv4 address. To identify it, the subnet mask is compared to the IPv4 address bit for bit from left to the right. The ones in the subnet mask identify the network portion, while the zeros identify the host portion. It's about subnet mask. And third IP address for configured is default gateway. Default gateway identifies the local gateway to reach remote networks. It will be some switches or routers and so forth. So continue. Our network address. Our network address is an identifier for node or host on a telecommunication network. Our network address, we find it by AND operation with IP address and subnet mask. As a result, we have network address. So continue. Prefix. As you can see in this slide, subnet mask is IP address that divided by 2 parts. One part have only ones, and second part have only zeros. And it can be useless, write something like this from time to time. For this, we use prefix. Prefix is a number that stands after slash, and this slash stands after IP address. So you can see this example. You have IP address, you have slash, and after this slash you see prefix. So you can see this also prefix and this subnet mask. You see it in a binary converter. So network, host, and broadcast address. We must find all of them. As I said before, network address is an operation between IP address and subnet mask. This This address is finished by 0, or all network address is finished by 0. Last element is 0. Last IP address is octet finished by 0. So next IP address from after network address is first usable host address. Here I have some formula. It's like a life hack from me. First usable host address is a network address plus 0001 converted to binary. It means that you have 8 zeros here, 0, 0, 0, 0, 0, and so forth. Here also 8 zeros, also 8 zeros, and here you have 7 zeros and 1 and 1. And in the end of these zeros, broadcast address is AND operation between IP address and this subnet mask. Last usable host address is broadcast address minus this IP address. Yes, converted to binary also. Yes. Uh, for continue. Where is it used? Where we use these elements? Where use broadcast? Where use network address? Where we use these usable host addresses? I have some situation when we use it. Just for example, when you want to connect to Wi-Fi and throw a request to router for its domain name, you call the domain name, but under this name is broadcast address, and you call him. In IP range of IP address from first to last usable host addresses. It gives you IP address, and you use them to connect to the internet by its network address. So I have this something like paints work. You have one device. You connect to some router, switch, or something like this by the domain. Yes, something like SD Wi-Fi. Yes, it's domain name, but under this domain name you have default gateway is IP address. You call him and it find you some IP address in this range from first to last, give you, and by using them you connect to internet with this network address. So continue. We know how it works, how we connect to internet. So let's see communication in the internet by this IPv4 standard. A host connected to a network can communicate with other hosts in one of these three ways. Unicast, you see this, is unicast is the sender. One sender to one receiver. Broadcast, when you have one sender and all elements that connect to you is receiver. Multicast, when you have more than one receivers, but not all of these users. So it's how you communicate with other devices. So that's all. Thanks for watching. Subscribe, put like. So thanks for watching. Goodbye.